C, we're looking for the second derivative. So we're going to first of all differentiate once. So differentiating this once, I'm going to end up using the quotient rule. So I'm going to differentiate e to the x. I'm not going to differentiate the denominator, minus e to the x, and differentiating the denominator, I get e to the x plus 1. Okay, and that's all over e to the x plus x all squared. Now, it's really important to try to simplify this the best we can, because the second derivative is going to be really messy if I don't simplify this. So I'm going to simplify this expression. So I'm going to just first of all multiply this all out. 2x plus x e to the x minus e to the 2x. So it looks like those e to the 2x's will cancel out, minus e to the x. Okay, and that's all over e to the x plus x all squared. Okay, I'm going to cancel out these terms disappear. I'm going to factor that e to the x out and see what I'm left with. And so when I factor that out, f prime of x is equal to e to the x, and then I end up with x minus 1, and it looks like there's no common factors here. So at this point, I have to decide, do I want to differentiate the factored form? That means I have to embed the product and quotient rule together. And that doesn't look too bad, so I'm going to leave it like that and differentiate this expression instead of having the unfactored form. Okay, so working on this second derivative, I'm just going to differentiate the first derivative again. So I'm going to differentiate the numerator using product rule. So it's going to be e to the x times 1. So there's my product rule. Okay, for the numerator, I need to do this in the context of quotient rule. So then I need to bring the new denominator up and not differentiate it in this step. Okay, the quotient rule means I don't differentiate the numerator, okay, but I differentiate the denominator, which is an embedded function. So I have to first differentiate the squared function, and then I differentiate the inside to get e to the x plus 1. So applying chain rule here. Okay, so this portion is a chain rule of differentiating the denominator. And then the denominator, I just add an extra power onto that. Okay, so there's my second derivative. Now, we should simplify this, but this is a usable second derivative. So if I need to use it to calculate slope, I can just use that expression. However, I really should see if there are like terms that cancel out. Oh, this is really messy, but I'm going to attempt to simplify this expression. So I'm going to get x e to the x minus e to the x plus e to the x. So that's definitely going to simplify. I'm going to simplify that before I multiply that out. I'm going to expand this out, e to the 2x plus 2x e to the x plus x squared, okay, minus, now this looks a little bit messy, so I'm going to e to the x, so x e to the x minus e to the x. I'm going to multiply that into the first set of brackets. So I've done this into here, and then I'm going to expand out what's in the square brackets there. So I'm going to end up with 2e to the 2x. Okay, first outside is e to the x, so it's going to be plus 2e to the x. Okay, inside is going to give me plus 2x e to the x. And then last is going to give me plus 2x. Okay, so I'm multiplying the 2 and expanding the brackets at the same time. Okay, I'm going to keep the denominator factored. because in the end, what my simplification will involve is if I can maybe find some common factors. Okay, otherwise, I'm just looking for combining like terms here. So cancel, get rid of those. Okay, there's no like terms here, no like terms in there. Okay, so I'm going to expand out the first set of brackets. Okay, so I'm going to end up with e to the x. This expanded into that bracket, right? So I end up with, I'm just going to make sure I have done it properly here. It's going to be x e to the 3x, and then it's going to be plus 2x squared e to the 2x. Okay, and then it's going to be x cubed e to the x. So that's the first set. Expanding out this next set of brackets is going to be really messy looking, but hopefully it generates some like terms. Okay, so multiplying out this second set of brackets, I'm going to end up with 2x e to the 2x. That's going to be the first. I'm going to just multiply the first term out onto those four terms. So this is going to be, let's put brackets in there. So x is going to be plus 2 x e to the, sorry, that's going to be 3x here. It's going to be e to the 2x. This next one's going to be plus 2x squared e to the 2x. The next term is going to be 2x squared e to the x. Okay, and then we have to expand out the next set of brackets here. This ends up being minus 2x e to the 2x. Next term is going to be, oh, sorry, that's not going to be 2x, sorry. It's going to be 2 e to the 3x. Then we get 2 e to the 2x. Then we end up with minus 2x e to the x, minus 2x e to the 2x, and then 2x e to the x. So 2x e to the x. Just double checking my work here. So that's going to be the last term multiplied out. Okay, so then we have the whole numerator expanded, and we can then work out, combine any like terms in there. Okay, so there's a lot going on in here. Again, just a reminder that we could, this expression here, we can use to find a derivative or a slope if we need it. So combining any like terms here, so I'm going to group my like terms here. I've got like terms here, here, and looks like those two are like terms. So I'm going to start combining my like terms. So I end up with negative x e to the 3x. Okay, looking for some more like terms. X squared e to the 2x. It looks like I have another one here. So putting that together, I end up with, those are going to cancel out. Okay, so I'm going to just cancel those ones out. X cubed e to the x. Okay, we have no x cubed e to the x terms. And it looks like that's the only like terms I have here. Okay, so I'm going to group together a couple other like terms here. I see I have 2x e to the 2x, and it looks like that's about the only other like terms that I have. Okay, so grouping those together, those are going to actually cancel out. Okay, and then all the other terms, it looks like I have non-like terms for the other terms. So x cubed e to the x, okay, minus 2x squared e to the x, minus 2 e to the 3x, minus 2 e to the 2x, and minus 2, well, these are going to be pluses, sorry. It's going to end up being plus, plus, and plus 2x e to the x. Okay, so that's my simplified form. I can factor out an e to the x. It looks like that's the only thing I can factor out. I don't have a factor of e to the x in the denominator, so I'm going to leave it like that as my simplified form.